Hello students, can you hear me, all of you? Okay, so I've been told that you are having your exam in your school for the first three chapters, uh, I guess on 15th May, right? So, or by 15th May, yes? Okay, so like in the first three chapters, one chapter is physical, physical world, other chapter is um, unit and dimensions. Third chapter will be kinematics in 1D. So till 15th May we have ample of time. But I want you to read the chapter physical world by yourself, because in that chapter there are only examples that what is physics all about and what are the examples by which, well, he has just told some stories that how can we relate our nature to the physics and how come all the phenomenon can be explained by the physics, how all the logics can be derived from the physics. So this is all that they have covered in that. Yeah, in the second chapter you will be seeing about units and dimensions, and we will take one class on that chapter, and later on we can take the doubts, right? So we'll continue with vectors in, I guess, two classes. I guess we shall be able to finish our vectors. Then after that we can start with our unit and dimension, and then the next chapter. Though there is one more chapter which I need to teach you before we study kinematics in detail, because for the IIT JEE level it's not only formula based questions, right? So we have to study some basic mathematical tools which I'll be teaching you. You are going to study about these tools in detail in your 11th as well as the 12th class in your mathematics subject. But I'll be giving you a brief introduction of how different functions are, and how to plot the graphs of different functions, then what is differentiation, what is integration, as I have told you, right? So we will be studying about this a little bit so that we are able to apply all our concepts in physics efficiently. Yeah. Anyway, so no need to worry about the exam. I'll give you some tips how to write in the exams, especially in 11th and 12th class. What are the types of the questions, right? So we'll continue with our syllabus today. Okay, so in the last class we were discussing about how to add two vectors, yeah, and we tried some problems. Do you have any question, any confusion in addition of two vectors? In the last class we learned that how to add two vectors. So let me start with brief introduction and brief revision. We have already studied, a physical quantity can be described into two parts. One is your scalar and other is your vector, right? So if a physical quantity can be described in these two, we already know how to add, subtract and multiply scalars. Yeah, but for vectors we need to study special rules. Yeah, so one of the rules that we studied in the last class, that was addition of vectors. If two vectors are given and obviously they will be inclined at any angle, it may be 0 degree, it may be any angle 0 to 180 degree. Yeah, so they will be inclined at any angle theta. Then how do we find the resultant, that is the net magnitude of the resultant vector? So in the last class we learned this formula, r is equal to square root of, if there are two vectors, vector a and vector b, so we wrote the magnitude as a and b, so it was a square plus b square plus 2ab cos theta. Yeah, so there shouldn't be any confusion between, see, this is your vector a, yeah, and if I write the magnitude of vector a, I can write it as like this, mod of vector a, or I can also represent the magnitude as simply a. Yeah, so there shouldn't be any confusion that what is the difference between these three. This represents the vector quantity, this represents the magnitude only, and this also represents the magnitude. So this is what we learned in the last class, and we also found how to find the angle between the resultant vector and the one vector a. So it was, if we are finding this resultant with vector a, then it was b sin theta divided by a plus b cos theta. Yeah, and if we are writing this angle, for example, this was our vector a and this was vector b. Yeah, so this was our resultant vector, which we said that it is, let us say, making an angle alpha. Yeah, then, and if this is angle beta, so if we are saying that resultant is making an angle, since resultant is also a vector, so we will have to define two things. One is magnitude, which we already calculated by this formula. Yeah, other is your angle of the vector, that is direction of the vector. Now, direction of the vector will be with vector A. Either we can define it that vector r is making an angle alpha with A, or we can say vector r is making an angle beta with vector B. Yeah. So if we are writing tan beta, then beta is vector with vector B. So we will write it as A sine theta, yeah, divided by, just these values will interchange. Yeah, so this will be A plus B plus A cos theta. So this is how we can write if we are given angle with A or angle with B. In both cases we can write the angle. Any confusion up to this? Okay, good. So we in the last class, since we already learned about how do we add vectors, now let us learn how do we subtract vectors. Yeah, how do we subtract vectors? See, we already learned special rule to add two vectors. Let us say I have been given this is one vector A, yeah, and say this is one vector B which is inclined to the horizontal at some angle theta. Yeah. So what is the angle between A and B? Angle between A and B, obviously we will shift this vector here, then we will find, and after joining the vectors tail to tail, then we can find out that the vector between angle between vectors is theta. But if I am asked, if I need to find, there is some vector r which is given as vector A minus vector B. How do I find this value? In the last class we learned that if vector r is vector A plus vector B, then how to calculate the value of this, right? But if we are given the subtraction, then how do we find the value of this subtraction? Now this can be written as vector A plus minus vector B. Yeah. So you can see this is essentially the case of addition of vector only, provided your instead of vector B you are getting minus vector B. Yeah. So now students, tell me, if angle between vector A and vector B is theta, then what will be the angle between vector A and minus vector B? Because if we want to apply the formula for magnitude of vector r, say I want to write this magnitude of vector r, this will be A square plus B square plus 2AB. Now if angle between A and B is theta, what will be angle between vector A and vector minus B? Obviously it will not be theta, it will be some different angle. Why? Because we changed vector B as minus vector B. There should be no confusion that why there is not minus here and why there is not minus B, because I have already told you magnitude of a vector is always positive. Yeah. So magnitude of vector A is also A, and magnitude of minus vector A, that will also be A. Yeah. So magnitude of a vector is always positive. Why? Because magnitude of the vector is what? Length of the arrow. Yeah. So it cannot be negative. But negative sign only signifies the direction is opposite to A. Now tell me students, if angle between A and B, vector A and vector B is theta, then what will be the angle between vector A and minus vector B? Vector A and minus vector B. Tell me, yes sir. Anyone? Angle between vector A and vector B? No. 90 minus theta. No. Incorrect. Yes, 180 minus theta. Very good. Rohini, did you get your answer? Anything? Right or wrong? Yes, 180 minus theta. Very good. Very good. See, if I am given this is vector A, yeah, and this is your vector B. Now what will be minus vector B? Minus vector B will be like this. Magnitude is same, just the direction is just opposite of vector B. So if this angle is theta, then if I reverse this vector, then what will be the angle? Obviously you have to join it tail to tail, right? So this becomes your minus vector B. Yeah. So earlier it was making an angle theta. Now what will be the new angle between vector A and vector minus B? It will become pi minus theta, or we can say 180 minus theta. Ashwani, understood? Ashwin? Okay, so angle between vectors is 180 minus theta. There is no confusion about that. So this is essentially the case of addition of two vectors. What are these two vectors? Vector A and vector minus B. Okay, so that's why Rohin is writing something. Is there any doubt? So if this is your vector A and this becomes your minus vector B, earlier vector A and vector B, this angle was theta. Trigonometric ratio sine or cos will remain same. See here, when we are using this formula, that is vector a square plus b square plus 2ab cos theta. Now when we were using this formula, we specified that this angle was the angle between these two vectors. What vectors? The vectors which we are adding. Now in this case we are adding these two vectors, vector a and vector minus b. So trigonometric ratio, it will, instead of cos theta, now it will become cos pi minus theta. Why? Because here we are already specifying this angle is the angle between the vectors, right? So this will become cos of pi minus theta, and I told you how to solve this cos pi minus theta or cos 180 minus theta. It can be written as minus cos theta. Clear? Okay, so we can see that this is essentially the case of addition of two vectors only, in which one vector is vector A and other vector is minus vector B. So we will put the value of theta as pi minus theta, because we already found that if the angle between vector A and vector B is theta, then vector A and vector minus B will make an angle of 180 minus theta. So we can write it as a square plus b square plus 2ab cos of pi minus theta, and cos of pi minus theta we already know, that will be minus cos theta. So it will be a square plus b square minus 2ab cos theta. So again, very important relation, we will always remember that magnitude of vector r, which is actually equal to what? Magnitude of vector a minus vector b. So this magnitude will be equal to this. See, there should be no confusion. You will not get confused by the diagrams, that how do we draw the diagram. Does not matter. You will be given the magnitudes of a and b, and you will be given the angle. You have to check whether you have to add them or you have to subtract them. And if you have to add them, just take the angle theta and apply this formula, that is a square plus b square plus 2ab cos theta. And if you have to subtract them, apply this formula, minus 2ab cos theta. How did we derive it? Does not matter. Is it okay? This modulus represent the magnitude. Yeah, this modulus represent the magnitude, and obviously since it represents the magnitude and it's already a modulus, so this value will always be positive. Okay. Okay. Any confusion? So please note it down. Subtraction of vectors. Yeah, subtraction of vectors. So this can be written as this one, vector r is equal to vector a minus vector b, which can be written as vector a plus of minus vector b. So angle will become pi minus theta, which we can write as a square plus b square minus 2ab cos theta. Let me know when you are done. Done. Okay. Okay. Write down a question. I'm dictating it. Ready? Okay. Write down. Two forces of magnitude 10 Newton and 15 Newton, two forces of magnitude 10 Newton and 15 Newton are acting at an angle of 60 degree. Two forces of magnitude 10 Newton and 15 Newton are acting at an angle of 60 degree. Then find the magnitude of, then find the magnitude of their vector addition, find the magnitude of their vector addition, or we can say vector sum, and magnitude of vector subtraction, and magnitude of vector subtraction. See, if these two forces, force say vector A, which is given as 10 Newton, and force vector B, which is whose magnitude is given as 50 Newton. So what you need to find? I just dictated you so as just to let you know what can be the language of the question, right? And this will be vector A minus vector B, and also you need to find all this. This is fourth part. Solve it. Yes, sir. Okay, first part, root 475. Very good. Correct. Okay. Rohini got it. Ashwin, this is second part, right? Yeah, very good. Correct. Root 175. So first is root 475, second is root 175. So this is 475. Unit will be Newton, and this will be root 175 Newton. Okay, third one. Guys, you're taking too much time. What is the answer of third one? Shouldn't be that long. Third one, minus 5. Minus 5 Newton. Very good. Minus 5 Newton. Okay. And the next one. Until did you get minus 5? Good. So next one will be 25. See guys, see, you must have applied the formula this a square plus b square plus 2ab cos theta in the first part, right? So 2ab cos theta, right? So you must have applied this formula. Then in the second part, you must have applied a square minus, sorry, a square plus, there is some problem with this. must be a square b square minus 2ab cos theta. Yeah. So this must be the formula for the second one. A square plus b square plus 2ab cos theta for the first one. Second one, a square plus b square minus 2ab cos theta. So you will get 4 roots of 475 and root 175. And we must understand that what is the difference between these two. That is this quantity and this one. Yeah. That is force vector a plus vector b ka magnitude and vector a minus vector b ka magnitude and sum of individual magnitudes. So when you are given this one, this is just the simple sum of the vectors. This is not the vector addition. This is the simple sum of magnitudes, right? So similarly, this is just the simple subtraction of the vector. If I would have given you this one, modulus of, that is modulus of vector A minus modulus of vector B whole modulus, then it would have been plus 5 Newton. Yeah, plus 5 Newton. Is it okay? So just understand the difference between mod of vector A plus vector B and mod of vector A minus vector B, which represent the magnitude of vector addition or vector subtraction. Then this represent the just subtraction of magnitude of vector and addition of magnitude of vector, which is actually the addition and subtraction of scalars, right? So write down the next question. Okay, so what you are given, if write down magnitude of vector A plus vector B, magnitude of vector A plus vector B, see this is vector, right? Vector A plus vector B, because I can't represent the arrow sign using typing. So if magnitude of vector A is equal to magnitude of vector A minus vector B, yeah, then find the angle between vector A and B. Right? Magnitude of vector A and vector B is equal. Oh, very good. Perfect. Great. Impressed. So guys, consider yourself very good, because I'm almost teaching 150 students. Yes, 90-degree correct answer. I'm teaching at least 150 students in my regular batches, and obviously some students are very good. Before I completed vectors, they already solved all the problems and all, asked me doubts. They are doing something else, but I can see you are very good. You are going very good. Yeah, and keep up this pace, and you will be able to learn a lot of good things. Okay, Rohini and Ashwin, did you get your answer? Ashwin, okay, Rohini, yes, good, very good. Okay, just write down the next question. If angle between vector A and vector B is 60 degree, if angle between vector A and vector B, this is a very small question, vector A and vector B is 60 degree, then find the angle between minus vector 2A and vector B by 2. So what you have given, angle between vector A and vector B is 60 degree, find the angle between minus 2A and B by 2. Yeah, what's the angle? What is the angle? No. There is some vector A? No. I'm asking between minus 2a and b by 2. Say this is your vector A and this will be your vector B, which is, yes, Ashwin, correct. This angle is given 60 degree. So this will be your minus vector 2a and vector b by 2. You have not changed the direction, you have only decreased its magnitude. So this will be vector b by 2. So earlier this angle was 60 degree. Now what will be this angle? 120. Understood? Rohini and Anchal? Okay. Now write down the next question. Write down. Resultant of two vectors, vector A and vector B, yeah, makes an angle of 45 degree with B. Okay, so if magnitude of A is 2 and angle between A and B is 60 degree, then find the magnitude of B. No answer, no true 3. Check your solution. Little bit of mistake. Yeah, correct. Perfect. Good. Ashwin and Rohini, what are you getting? Yes, I will. Okay. So let us see question number 3 first. Meanwhile, Anshul, you can solve the question number 4. Okay. Okay. So Rohini and Afshin, you can see resultant of two vectors A and B makes an angle of 45 degree with B. Now it is making an angle 45 degree with B, and see, whatever information is given, we will write it in our solution. First of all, we are given that beta, which is the angle with vector B, that is actually 45 degree. Okay. Now then magnitude of vector A, this is given 2. Now we need to find what is the magnitude of vector B, which is not known, and angle between these vectors is given as 60 degree. Now we know that formula. Actually, we know about tan alpha. Now we are talking about this tan beta, and you can see this angle is with B, right, not with A. So I told you, if we are seeing the angle with other vectors, then we have to switch the values, because earlier our formula was B sin theta divided by A plus B cos theta. Yeah, but in this case the angle was with vector A. Now we have the angle with vector B, so we can write it tan beta is equal to A sin theta divided by B plus A cos theta. We have just switched the values, right? Because if angle is with vector A, then this will be the formula. If angle is with vector B, then formula will be this. A and B will interchange. Now tan 45, we will put the value of beta as 45, tan 45 is 1, then is equal to magnitude of A is given, which is 2, theta is also given, sin 60, sin 60 will be root 3 by 2 divided by B magnitude that we need to find, B plus magnitude of A is 2, cos 60 is 1 by 2. Yeah, so what will be the final value? So this will be B plus 2, when we cross multiply, B plus 1 is equal to, this will cancel out and this will also cancel out. So B plus 1 is equal to root 3. So we can write B as root 3 minus 1. Understood? Okay, good. 2x cos theta by 2. Perfect answer. Very good. Rohini and Akshin, solve the question number 4 ASAP. Please note it down. If you have not solved the question number 3 or solved it incorrectly, then please note the solutions. It's going to help you in future while revision. Answer meanwhile, let me give you other question. Okay guys, I'm erasing the solution. Yes. If you are asked to find the resultant, we only mean that addition of these two vectors. We will not take subtraction unless mentioned in the question. Yes, 2x cos theta. Very good. 2x cos theta if x is the magnitude of one vector. Very good, Rohini. Ashwin, did you get this answer? 2? Only 2? Yes, perfect. So do I need to explain this? Question number 3? Solve this one. Ashwin, don't be in haste. And guys, when you have time now, note down the questions as well, because when you will revise, then you will be able to get that what did you solve exactly. Yeah. Not 60. What is the value that you are getting for cos theta? Tell me the value for cos theta from where you converted this angle. You get getting 1 by 2 or minus 1 by 2. It will be minus 1 by 2. That's why you are wrong. Correct. Answer correct. Rohini correct. Rohini, are you getting now 1 minus 1 by 2? Yeah. Cos theta is equal to minus 1 by 2? Yes. Good. Ashwin, check your solution. Let us solve. See, if magnitude of resultant of two equal vectors. So let us assume of two vectors of magnitude A and A is equal to magnitude of the either vector. That is, magnitude of the resultant vector is magnitude of the either vector. So they also have magnitude A. Now we need to find the angle. We will just apply the formula. So A square is equal to A square plus A square plus 2A square cos theta. Yeah, this is the formula, right? So this will be minus A square is equal to 2A square cos theta. So we can write cos theta is equal to minus 1 by 2. Hence theta will be equal to 120 degree. Okay. And doubt? Okay, good. Okay, let's go forward. Now, since we have already learned about the addition of two vectors, now we will discuss about, see, in this case we were having only two vectors. What if we have three vectors, four vectors, or multiple vectors, right? So we added two vectors using triangle law of vector addition. But if we are having say three vectors, four vectors, then we call it polygon law of vector addition. So you will write it as polygon law of vector addition. So name of the topic is polygon law of vector addition, right? So how do we solve in case of multiple vectors? So that we will be solving by polygon law. So how do we solve by polygon law of vector addition? Say this is your some vector A, then there is some vector B, right? Then there is some third vector C, and there is some other vector D. We need to add all these vectors. Then how do I add these vectors? See, what we have learned in that vector addition, that when we used to represent the vectors along two sides of a triangle, then what we used to do, we used to arrange them in a certain order. In a certain order means it may be anti-clockwise, it may be clockwise, but vector should be placed head to tail, head to tail, head to tail, and so on. Then the resultant vector will be from the initial vector, that is tail of the first vector, towards the final vector, that is tip of the final vector, right? So if we want to arrange these vectors, then how we will arrange these vectors, right? So let us take, say this is your first vector A, How did we arrange it? First vector A, which is actually placed as it is, right? Because we can shift the vectors. So let us say this is your vector A, which is vector A, right? Now, how do we draw this vector B? Vector B, vector B can be drawn because we can shift this vector parallel to itself. So this is your vector B. So vector B can be just like the triangle O, it is represented in the certain order. That is, we are joining the head to tail of each vector. Then how do we represent this vector C? Vector C, we will also shift it parallel to itself and such that its tail is on the vector B, as we discussed in the triangle O. Its tail is on the vector B and head is along C. We have not changed the direction of this vector and neither we have changed the magnitude of this vector, right? So again, this remains the same vector, just we have shifted it so as to arrange them in a order. So this will become our vector C. Now how we will shift this vector D? Vector D will be again shifted so that its tail matches the head of the vector C, and this will be your vector D, right? So if this is your vector D, then this is how we have arranged whatever vectors were available to us, right? Then if this is your vector D, then how we will write final vector, that is a resultant vector. So resultant vector will be from the initial position towards the final position. That is, this will be starting from the tail of the vector A and it will be going towards the tip of the vector D. So, and obviously its order will be in the opposite direction. So this is how we will get our final vector, that is in the opposite order. So this will be vector R. So we can write vector R is actually equal to vector A plus vector B plus vector C plus vector D. So this vector R, which is actually the vector joining the first point and the last point in the opposite direction, is the resultant of vector A, B, C and D. Now in this case, order does not matter. If you say, sir, if I take vector C first then take vector B, does not matter, right? So you can see in this case, you have written vector A plus vector B plus vector C plus vector D. You can also write it as vector A plus vector C plus vector B plus vector D. It is not going to make a difference, right? So you can also write vector B instead of vector C. In the figure also you can first draw vector C then vector D, but the result will remain same. It does not matter. Okay, any doubt? Rohini is writing something. No. Tail of the vector R is this one. This is the tail of the vector R. And this is head of vector D and this is head of vector R. It is in the same manner like we used in the triangle law, that is resultant vector will be in the opposite direction. It is in the same manner. Yeah? Okay. So is it understood? This is just like our triangle law. In triangle law, we arranged the vectors in a certain order. There were only two vectors, right? And the resultant vector we wrote it from initial position towards the final position. Similarly, in this case also, we arranged these vectors in the certain order and our final vector was from the initial position towards the final position. Any confusion? Okay. Just for in case if you might want to know, see how do we find the resultant of these vectors? If in actual we have to calculate, what we will do, see, first of all I can take a vector joining vector A and vector B. Yeah, so I will take a vector joining vector A and vector B. So this vector will represent that vector addition of vector A and vector B. So this will be actually my vector A plus vector B. Yeah, just from the triangle, just forget about all these vectors, just focus on these two vectors, vector A and vector B. So this resultant will be a third vector in the opposite manner, vector A plus vector B. Now you can see this vector A plus vector B. This is some another vector, and this is vector C. They are again in the same order. Now forget about these two, A and B. Just focus on these two, A plus B and vector C. Again, they are in the same order of the triangle law. So we can take a final vector starting from this tail and ending at the head of the vector C. Yeah. So again, this will become our vector addition of this vector and this vector. So it will be equal to what? Vector A plus vector B plus vector C. Yeah. So this vector becomes addition of vector A, B and C. And now you can see this vector and this vector D. Again they form a triangle. So this addition will be R is equal to A plus B plus C plus D, whatever, which we have written already. Is it okay? And out. Okay. So please note it down if you have not. Polygon law of vector addition. Done? Okay, good. Okay, guys. I'll explain you one more law to add two vectors. And this law is known as parallelogram law of vector addition, but I want you to read it from your Pradeep book. Yeah, you will read it from your Pradeep book. This is just similar to the triangle law of vector addition. Derivation is similar. I'll just tell you how do we do that. See, I told you that there are 2 to 3 laws for the vectors to add them, right? So one we already learned, triangle of vector addition. Next we are learning about parallelogram law of vector addition. So if there is some parallelogram, then how do we add this vector using a parallelogram? Earlier we used a triangle and we added the vectors at vector A plus vector B. How did we represent the vectors? In a certain order, that is along the two sides of the triangle. Then our third side was the resultant. In this case what we do, we represent the vectors along two sides of the triangle. So let us two sides of the parallelogram. Yeah. So let us say there are two vectors. Now you can see the order is different. Here we are joining them tail to tail, right? So if we are saying that if there are two vectors which are represented along the two adjacent sides of the parallelogram, then their resultant will be along the diagonal of these two vectors. The resultant will be along the diagonal of these two vectors. Let us say this is point C. Yeah. So their resultant will be along the diagonal of these two vectors. So this will become the resultant of the vector. Now obviously, if I add, to solve a particular question, we can have various methods, but our answer is never a different thing, right? So answer cannot change whether we solve it by method 1 or method 2 or method 3, does not matter, right? Similarly in this case, whether you add vectors using parallelogram law or triangle law, addition must remain same. So in this case also, if two vectors are represented along two adjacent sides of a parallelogram, then the diagonal will actually represent the magnitude of the resultant vector. Diagonal will represent the magnitude of the resultant vector. So this will be your vector A plus vector B. Yeah. Again, I'll just tell you the proof in brief. See, if this is a parallelogram, then opposite sides are equal and parallel. If opposite sides are equal and parallel, then I can represent this side as vector B. If I can represent this side as vector B, then you can see this again became a triangle law. So again, everything will remain same. You will drop a perpendicular, then whatever the whole story is the same. Yeah, that's why I told you to read from your Pradeep book. Will it be done? Is it okay? Yeah. So only difference is, see, formula is also same, because obviously you are going to derive the triangle law again. So you have to derive it by yourself on your notebook for the practice purpose, because in school exam they generally ask for the derivation, right? So that's why I'm asking you to practice it on your notebook by yourself, right? So in this again you will derive the triangle law only, and the formula will remain same. That is, magnitude of vector r is equal to a square plus b square plus 2ab cos theta. Similarly, formula is same for the direction of the vector as well. Clear? Okay. So just read it from your Pradeep book. we'll go. Did we learn about how do we split vectors? Did we discuss how to resolution of vectors? Okay, so we have already covered that. And uh, means how to write the components of a vector. We have already covered that, right? Yes, yes, yes. I remember. Yeah, I gave you four to five vectors on the axis. Yeah. Okay. Fine. Okay, guys. Next we are going to start. See, we have already seen now that how do we add vectors and how do we subtract vectors. We already learned these two topics. Now we are discussing how do we multiply vectors. How do we multiply vectors? See, when we have to multiply vectors, for scalars, we have rules to multiply, like for example, 3 into 2. Yeah, 3 into 2 is 6. That is the rule that we already learned in our junior classes, right? But what if we have to multiply vectors? So multiplication of vectors can be of two types. Please note it down. Multiplication of vectors. Multiplication of vectors, right? It can be of two types. Write down. One is dot product. One is your dot product, other is your cross product. One is your dot product, other is your cross product. This is also known as scalar product. Scalar product, and this is known as vector product. Vector product. And why there is a name dot and cross? Because if you multiply, if you take the dot product of two vectors, vector A and vector B, then you will take it as vector A dot vector B. Yeah. So sign symbol makes a lot of difference. If it is a dot, then it is dot product, and in case of cross product, how do you write? Vector A cross vector B. So this is the symbol of your cross product, right? So dot product, cross product. This is your scalar product. This is your vector product. A dot B, A cross B. Okay. Now why this is called a scalar product? Because whatever is the resultant quantity, that will be a scalar quantity. So write it down. Resultant quantity of dot product. Resultant quantity of dot product is a scalar quantity. Resultant quantity of a dot product is a scalar quantity. And in this cross product, write it down. Resultant quantity of a cross product is a vector quantity. Resultant quantity of a cross product is a vector quantity. We'll understand it later on how it is a vector quantity. Yeah, we are not interested in that right now. We will be discussing first dot product, and we'll try to cover it today itself. Dot product. What do we mean by dot product? As I already told you, if I represented vector A and vector B, then dot product is written as A dot B. Vector A dot vector B. So let us say there are two vectors, vector A and vector B, inclined at angle theta. Now you will be asking, sir, why do we need to learn dot product? Means what is the significance of this dot product? In your ninth class, you must have learned that work done is equal to F into S. Yeah, but you might have noticed that this work done, when you used to calculate using force and displacement, in this case always force was either in the direction of displacement or it was in opposite direction of the displacement. And you also know that force and displacement both are vector quantities, so you cannot multiply just like that, right? But what was the case? Because they were either in the same direction or in the opposite direction, so vectors did not come into picture, and you didn't know, unknowingly you were multiplying the vectors, right? So work done is actually a scalar quantity, and work done is defined as vector F dot vector S, that is multiplication of force and displacement vector using dot product. Now if I have to write dot product of two vectors, vector A dot vector B, that was equal to magnitude of A, which is A, B cos theta, where theta is the angle between these two vectors. Now this is the formula of the dot product. Vector A dot vector B is equal to AB cos theta, right? So this is how we write the dot product. Similarly here, we can write W is equal to F S cos theta, right? Now, in your ninth class, what was the case? Force was always in the direction of displacement. If force is always in the direction of displacement, then cos theta will remain 1. So, did not make a difference whether you use vector W is equal to F into S or vector F dot vector S if both are in the same direction. If both are in the opposite direction, then cos theta will become -1. So in that case, you might have studied negative work, right? So in that case, it was -1. So you used to take the work as a negative, right? But actually, it was AB cos theta or FS cos theta, right? So using the value of theta, you can change it. Is it clear? So that is how we define dot product. Okay. Just note it down that how do we represent dot product? Vector A dot vector B is equal to AB cos theta. That is how we write the dot product, and resultant quantity is a scalar quantity. Okay, any confusion? Okay, Rohini. Okay, no doubt. Okay, so just find the dot product of two vectors. Say two vectors of magnitude 3 unit and 4 unit, two vectors of magnitude 3 unit and 4 unit. Ashwini, write down a question. Two vectors of magnitude 3 unit and 4 unit. Ashwin, can you hear me? Yeah, I was dictating a question. Two vectors of magnitude 3 and 4 unit. Two vectors of magnitude 3 unit and 4 unit are at an angle of 60 degree. Find dot product of these two vectors. Ansel, what are you doing? Two vectors of magnitude 3 unit and 4 unit inclined at an angle of 60 degree. Find the dot product. How much? Yes. 3 and 4, yes. 6. Okay. When work done will be negative. Ansel, did you get 6? Okay, good. Ashwin, can you hear me now? Hello, Ashwin? Okay, Rohini, let me tell you. See, we were discussing about why work done. Work done is actually equal to vector F dot vector S, right? So we can write it as F S cos theta. Now, for example, if there is a body and you are applying a force of say 20 Newton on the body, and body is moving in the forward direction, say its displacement is 20 meter, then you can see the force and the displacement both are in the same direction. So this cos theta will become 0. Yeah, cos theta will become 0. Then if cos theta is 0, then cos 0 is 1. Right? So in that case, work done will be positive. But if, for example, displacement body is moving in the forward direction, you are applying brakes on your car, then obviously force is acting in the backward direction. If force is acting in the backward direction, then obviously angle will become 180 degree, and cos 180 is -1. So in that case, work done will be negative. So if you are doing if you are applying force in the opposite direction, then work done becomes negative. If you are applying force in the same direction, then work done will become positive, right? So this was as far as our ninth class was concerned. But in this case, we can also see when the work done will be positive. Not only when both are in the same direction, but when the angle between them is 0 to 90 degree. Because I told you all trigonometric functions are positive in the first quadrant. That is when the angle is 0 to 90 degree. So when the angle is 0 to 90 degree, then your cos theta, sin theta, every trigonometric function is positive. So cos theta will also be positive in 0 to 90 degree. So when the force and the displacement they are in the same direction, that is angle 0 degree, or at any angle which is between 0 to 90 degree, work done will be positive. But if the force and the displacement are at an angle of 90 to say 180 degree, if 90 to 180 degree, then in that case you can see cos theta is negative, right? So if cos theta is negative, then work done will be negative when the angle is 90 to 180. Understood? Anshul and Vaini, did you get it? Okay. Now, okay, write down. We are discussing some characteristics of dot product. Characteristics of dot product. Characteristics of dot product. Now we'll write the first characteristic. See, if a vector is multiplied by itself, for example, there is some vector A. If I multiply the vector by itself, what will be the angle between these two vectors? Vector A dot vector A. What will be the angle between these two vectors? 0. Very good. That angle will be 0. Magnitude, say magnitude is A. So it will be A cos 0. Cos 0 is 1. So when a vector is multiplied by itself, its magnitude will be A square. Yeah, perfect. So this is the first property. So when a vector is multiplied by itself, then magnitude is, it is equal to square of the magnitude of the vector. Okay. Then second property. Similarly, we can multiply the standard unit vector along x-axis, y-axis and z-axis. Ashwin, can you hear me now? Oh my lord, he cannot hear. Ashwin, hello. Anchal and Rohini, you can hear me now, right? Ashwin, can you hear me? Okay, we'll write the second property. See, as I told you, that a vector multiplied by itself is equal to square of the magnitude of the vector. Now we can write it in the standard unit vector. So what will be I cap dot I cap? I cap is a standard unit vector along x-axis. Now tell me what will be the value of this? Yeah, Anchal, Vaini. I cap square. Okay, see, that's what I was trying to get at. See, bacha, I cap. I cap is a unit vector. Now, this is a vector quantity. This is a vector symbol. If I write it as magnitude of I cap, what will be the magnitude of I cap? Since this is a unit vector, its magnitude is 1, right? So I can write it as magnitude of I cap into magnitude of I cap into cos 0, 1. So this will be 1, not I cap square. I cap is a vector beta, so we are already writing it as dot product of two vectors, vector A dot vector B. So this will be magnitude of A, magnitude of B into angle cos of angle between them. Understood? I cap is a vector. You cannot square them. You cannot square vectors. Yeah. The magnitude of unit vector is 1. Right? Okay. Tell me, if I have a vector I cap plus j cap, is this a unit vector? Good. This is not a unit vector. Anchal, are you clear about this? This is not a unit vector, right? Yes, good. So this is not a unit vector. Okay. Anyway, let us, if I ask you ki this is some vector A which is equal to I cap plus j cap, then what will be this unit vector? If I ask you, write the unit vector of vector A, what will be the unit vector of vector A? That is, I want you to write A cap. What will be A cap? Rohini and Anshul, both of you have audio access if you want to use it. What will be the A cap? Anshul? Anshul, Rohini, anyone? Magnitude of no beta, I am asking you A cap. This has nothing to do with dot product. You are getting confused with dot product. We are discussing dot product here, but I just asked you some other question. I told you how to write a unit vector of any vector. How do we write it? Vector divided by its magnitude. Yeah, that is how we write a unit vector. Correct? Are you getting it? Yes. So this has nothing to do with dot product. I just asked you. Let me check whether you know it or not. So what is the magnitude of this vector? So this is vector A. I have to divide it by the magnitude of vector A. What is the magnitude of this vector? 1 square plus 1 square. So this will become root 2. So A cap is I cap plus j cap divided by root 2. So this becomes a unit vector of vector A. Anshul, is it clear? Rohini? Anshul and Rohini? Okay. Rohini, is it clear to you? No, we did not assume the magnitude to be 1. See, this coefficient is 1. This coefficient is also 1. If I give you, say, 2I cap plus 3j cap, there is some vector A which is given as 2I cap plus 3j cap. And if I ask you that write the unit vector of vector A, then this will be vector A, which is 2I cap plus 3j cap. Divide by the magnitude of vector A. This will be what? Magnitude of vector A? 2 square plus 3 square. So this will be 4 plus 9, right? Root 13. So this will be your unit vector in this case. Yeah. And in case of standard unit vector, this I cap and I cap. These are the standard unit vectors. Obviously, their magnitude has to be 1. Yeah. Similarly, if you ask about the magnitude of this one, then this A cap, this will also be 1. Magnitude of this vector A is root 13, but magnitude of this quantity is again 1 because this becomes a unit vector. Is it clear? Okay, good. Doing any doubt? Okay. So we were discussing about the properties of this dot product. I cap I dot I cap is equal to 1. Now, similarly, if I write j cap dot j cap, that should be equal to k cap dot k cap, and this must be equal to 1 as well, right? Similarly, tell me, if I write I cap j cap, what will be the value? I cap dot j cap. So what? We can we can take dot product of any two vectors. It is not necessary for the two vectors to be same. For example, vector A dot vector B, I can write it as AB cos theta, whatever be these two vectors. Similarly, these two are unit vectors but along different axes. What are their magnitudes? AB cos theta. Magnitude of A, that is this vector I, is 1. This magnitude is 1. Now, what is the angle between them? What is the angle between vector I cap and j cap? 90, and cos 90 is what? Yes, 0. Rohini, are you getting it? See, I can write it as 1 into 1 cos 90 degree, and cos 90 is 0. So this will become 0. So dot product of any two standard unit vectors perpendicular to each other, that is I cap j cap, it can be j cap dot k cap, yeah, it can be I cap dot k cap. So all this will be equal to 0. Is it understood? Yeah. So dot product of vector with itself is 1, and with other standard unit vector it will be 0. Okay. Now, since we have already written that dot product of vector A dot vector B is equal to AB cos theta, right? So this is how we get the dot product. But what if two vectors are given in the standard unit vectors? For example, if I am given vector A is equal to AX I cap plus AY j cap plus AZ k cap. So this is my vector A. Now my vector B, let us say this is given as Bx I cap plus By j cap plus Bz k cap. These are my two vectors which are along these standard unit vectors. Now someone asked me that what will be vector A dot vector B. So I will write it as Ax I cap plus Ay j cap plus Az k cap dot Bx I cap. Find me the value. Bx I cap plus By j cap plus Bz k cap. See guys, in this case, we just like scalars, we can open up the bracket, that is, first of all, we will have the dot product of this term Ax I cap with Bx I cap, then dot product of Ax I cap with By j cap as we open the bracket, then with Bz k cap, and we will see with I cap, j cap, or j cap it will become 0 or it will convert into magnitude. That you have to see. So open the bracket and get me the final value. See, bacha, ax I cap, right? When you multiply ax I cap with bx I cap, now both are in the x-axis, so what will be angle? 0. When you multiply ax I cap dot by j cap, now this ax I cap is along x-axis again, and this by j cap becomes along y-axis, so angle becomes 90 degree. This is the beauty of representing the vectors in standard unit vectors. You do not need to find angle between these two vectors as a whole. Yeah, you can just multiply just like that in ijk. Okay. So Rohini, can you listen? Okay, 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 okay. See, I am writing it down. First of all, I'll multiply. I'll have dot product of ax with bx. Yes, perfect answer. Very good. So first of all, I'll have dot product of ax with bx. Ax I cap dot bx I cap. Then ax I cap dot by j cap. See, ax I cap dot bx I cap. So it will be ax into bx because angle is 0. Magnitude is ax. In this case, magnitude is bx. So it will be ax bx into 1 because cos 0 is 1 plus ax I cap into by j cap. That will become 0. Why? Because I cap and j cap both are inclined at 90 degree. So cos 90 is 0. So dot product will also become 0. Then ax I cap plus bz k cap. It will again become 0 because x axis and z axis again angle is 90 degree. Then ay j cap bx I cap. I'm taking the second term now with and I'll have the dot product with all these three terms. Ay j cap dot bx I cap 0 because j and I perpendicular. Similarly, ay j cap by j cap. So it will become ay by plus ay j cap bz k cap 0 plus az k cap bx I cap. This again 0 k and I. Then az k cap by j cap again 0 az k cap bz k cap. So this will be az bz. So ultimately I can write it as ax bx plus ay by. This is just for the understanding purpose. Later on we will just directly multiply. When we will solve question, we will just directly multiply I cap with I cap, j cap with j cap, z cap, k cap with k cap. We will not think about these two, right? Because we obviously know I cap j cap will be 0, I cap k cap will also be 0. Understood? Any doubt? Okay. Now let's go for let's move forward. See, this dot product is also very useful to find the angle between two vectors. For example, if I want to know angle between two vectors, vector A dot vector B, I already know this is written as AB cos theta. So if I want to find angle between two vectors, we will find A dot B as we just solved, and these are the magnitude of vector A and vector B. So angle between two vectors can be found out by writing vector A dot vector B divided by AB. Ashwin, can you hear me now? Okay, beta, you missed a lot of things. Anyway, I'll just cover that. Let me give them a question. Anshul and Rohini, is it clear? Anshul, any doubt? Beta, we do not take any value. For example, if vector A is this, it can be written as this: 2i cap plus 3j cap plus 4k cap. This is your vector A. Yeah. So, but if you want to write what is A, or you can say what is magnitude of A, that will be a number which will be 2 square plus 3 square plus 4 square. Otherwise, a vector will always be represented in this I cap, j cap or k cap, or it will be said that this is inclined at some angle this of magnitude this. So this is how we write. Yes? No, I didn't get you. So basically, they dot. No, no, no. If you are talking about these two vectors, what you write their value? Yes. If you talk about these two vectors, dot product of two vectors, then their value will become a number only because you have already multiplied, and we know that dot product is a scalar quantity, so that will be a number. But if you are asking about how do we write any vector A, that will be in the form of direction as well because a vector has a direction also. Am I clear now? Okay. So if we are writing vector A dot vector B, then whatever we will get after multiplying, then that will be number only. Yeah. Okay. So Just write down a question. Anshul and Rohini, write down a question. Uh, if vector A dot vector B is equal to AB, find angle between A and B. Find angle between A and B. Second question है, find angle between find angle between y-axis and I cap plus j cap plus k cap. Yeah, first is 0. Good. First is 0. First is 0. Rohini, did you get that? Yes. Okay, good. So solve the second question. Find angle between y-axis and I cap plus j cap plus k cap. Okay. Note this down. I am going to switch over the page. Find angle between y-axis and I cap plus j cap plus k cap. Okay. Ashwin, you'll pay attention. I'll just let you know what we covered. See, I was telling that how do we write dot product? Dot product of two vectors is equal to a plus a dot b is equal to ab cos theta. Vector a dot vector b is equal to ab cos theta. That is magnitude of a, magnitude of b into cos theta. Then after that we discuss some properties. If a vector is multiplied by itself, then it will be equal to magnitude of a into angle will be 0, so this will be 1, a square. Similarly, if we talk about standard unit vectors, I cap dot I cap, then magnitude of I cap and I cap is 1, right? So I cap magnitude is 1, magnitude of I cap again 1, and angle would be 0. Oh, sorry, angle 0, so cos 0 1. So it will be 1. So I cap dot I cap will be 1. Very important result. Then after that, this we were just discussing that how do we write unit vector. For example, if you are given any vector a which is equal to I cap plus j cap, then its unit vector will be I cap plus j cap divided by magnitude of vector a. No beta, not 90 degree. Rohini, not 90. Right? Okay, Ashwin. So j cap dot j cap will also be 1, k cap dot k cap will also be 1. Why? Magnitude is 1 and angle is 0. So cos 0 is 1. Similarly, I cap dot j cap will be 0 because angle becomes 90 degree, which is also 0 for j cap dot k cap, is also 0 for I cap dot k cap, right? So then after that we discussed if these two vectors are given in standard unit vectors, cos theta is 1 by 3, 1 by, it will be 1 by 3 or no, it will not be 1 by 3, it will be 1 by root 3. Anchal, 1 by root 3. Oh, Ashwin, you can't hear me now? Anchal, are you getting 1 by root 3? Rohini, are you getting? Okay, we'll solve. No problem. Yes, there is some network problem. Can you listen me now? Yes, 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 yes. You live in what, Dubai, Ashwin? Or where? Ashwin, can you hear me now? I guess he can't hear me. Anyway, how come his network is always slow? Okay, Rohini, Anchal will solve our question. Rohini, what are you getting? Okay, no problem. See, you have been asked to find the angle between y-axis and this vector. You need to find the angle between y-axis and this vector I plus vector j, I cap plus j cap plus k cap. This is some vector. So let us say there is one vector A. That vector is along y-axis, right? Y-axis, along y-axis we can write vector A as vector and as j cap. Then there is some other vector B is equal to I cap plus j cap plus k cap. Understood up to here? And out, Rohini and Anchal? Okay, very good. So now we need to find angle between these two vectors, and we know that vector A dot vector B is equal to AB cos theta. So that is how we can find the angle between these two vectors, right? So A dot B, it will be J dot I cap plus J cap plus K cap. It will be equal to, what is the magnitude of A? Since it is a unit vector, it will be 1. What is the magnitude of V? Magnitude of V will be 1 square plus 1 square plus 1 square. So it will be root 3 into cos theta. Okay. Now, when we open this bracket, and we already discussed j cap dot I cap, it will be 0 because angle is 90. J cap dot j cap, it will be 1. So j cap dot k cap, again it will be 0, right? So it will be j cap dot j cap, which is equal to 1. 1 is equal to root 3 cos theta. So cos theta we can write as 1 by root 3. Anchal, where were you wrong? Is it clear now? It will be root 3. Ashwin, can you hear me now? Anchal, is it clear to you that magnitude will be root 3? From here, Rohini? From here? Okay. See, we need to find the angle. Okay, Ashwin. Okay. I'm just explaining this question again. See, we need to find the angle between y-axis, so we took the vector A as j cap, right? And vector B was already given I cap plus j cap plus k cap. Now, we know that A dot B is AB cos theta, right? And value of vector A, as we already discussed, y-axis j cap, and value of vector B is given as I cap plus j cap plus k cap, right? So how do we find the dot product? As we discussed, AX I cap plus AY j cap. Similarly, in this case also, j cap dot I cap, j cap dot I cap, it will be plus j cap dot j cap plus j cap dot k cap. Now this will be 0. Why? Angle is 90. This will be 1. Magnitude is 1 and angle is 0. So cos 0 is 1. And this will also be 0 because angle is 0. So this will be 0 plus 1 plus 0. So it is equal to 1. And magnitude of vector A is 1 and magnitude of vector B square root of 1 plus 1 plus 1 root 3. Cos theta is equal to 1 by root 3. Ashwin, is it clear to you now? Or shall I explain from the previous part? Okay, good. So just remember, in the previous case also, I'll just show you the page. When we discuss for general vectors ax I cap plus ay j cap plus az k cap, in that case we actually discussed ax I cap plus ay j cap plus az k cap into this. So only the same direction magnitude will be ax bx. Rest ax I cap with by and bz will be 0. Same goes for ay j cap. So that's why it became x dx plus ay by plus az dz, because in the same direction it will be 1, and with others, like for example of I with j and k, it will be 0 because angle is 90 degree. Any confusion, guys? Okay, is it clear now? Dot product, more or less we have completed our dot product. Is it clear? Okay. See, I guess by tomorrow, uh, I'll mail some questions to you, right? And along with what you have to solve from your home, yeah. And we may discuss these questions in the next class also. So in the next class we will be okay. Tomorrow we are having class, right? Anyway, I'll just try to mail, but I'll be getting only after 8. Okay, anyway, by tomorrow you'll be getting an assignment, so which we may discuss in the next week, and we'll also mail you that how many questions do you have to solve. But just before coming to class, if you get the assignment, if you get the mail before the class, then just look at the assignment, because you just might see the type of questions that you may be facing, right? So just look at the assignment, just go through it once, see what are the type of questions. So if there is any further confusion, then you may ask me in the class, provided you get that mail before the class, because tomorrow I'll be going to the institute and I will mail that assignment after getting from my institute. Okay. Okay, so we'll finish our class here, and tomorrow we will discuss some more properties of this dot product, then we will start cross product, and tomorrow we'll try to finish our vectors. Okay, so tomorrow we'll be discussing some one or two problems on dot product, then we will discuss cross product. Any confusion, any doubt, any query? Just after vectors we will be solving dimensions. Just after vectors, though dimension is very easy topic. Dimensions, it shall take me around one lecture, physical world and dimensions. It may take one lecture on this units and measurements and error. We'll see. After vectors, tomorrow we'll finish vectors, then we'll start dimensions and our chapter from our NCRT. Fine. Any other query? Okay then. Thank you so much. See you in next class.